we have a posterior scissor bite that is only affecting the most distal tooth. We have to pay lots of attention to biomechanics to make sure this is going to happen as expected. Also, we have to analyze what's the problem that has been creating this scissor bite, because it might be a compression in the lower arch, overexpansion in the upper arch, or a combination of both. If we take a look at this case, we will see how there's an overexpansion in the upper arch of that upper left second molar, and in the lower arch we have a slight compression of the lower left second molar. If we get to the treatment plan, we will check this is happening, and we can see the contact of the palatal upper cusp and the lower buccal cusp. To solve this, we have to pay attention to the biomechanic from both arches separately. First of all, we're going to take a look at the upper arch. Since the first molar in the upper arch is compressed, it is really favorable to expand that molar and compress the second one. As you can see, we're having this movement. The thing here is that there is a previous distalization to create some space to be able to fully expand the first molar. So we know this is highly predictable because at these stages there is a simultaneous movement in both of them. So as you can see, we're having a movement of both, of 26 and 27 from aligner number 6 to aligner number 10, and the second stage of compression of the second molar. So this is really favorable from a biomechanical perspective. Compression of one segment associated to expansion of the other. Compression, expansion, compression, and expansion. That said, we have to take a look at the occlusion and at the position of the lower arch. In the lower arch, as we were saying, there is only a slight compression. Therefore, the CAD designer has planned some expansion. As you can see, it's just changing the torque of the crown, which is a predictable movement, as we all know. The thing is that we have to take also a look whenever we're having these transversal problems. We have to make sure that overjet is okay, that the final occlusion is okay. As you can see here, there's been a problem in the design the CAD designer has made. As you can see, the compression, we know it's favorable in the upper arch. So upper molar ends up in this situation, which is creating already some contacts, some interferences with the lower one. And unfortunately, the CAD designer has been designing the lower arch based on an ideal arch form, and it's creating some more interferences. So we should delete. This is an ideal position, the occlusion of both, but if the CAD designer is planning this additional expansion in the lower arch, this is going to avoid the upper compression to happen or the lower expansion to happen. Therefore, what we should do in this case is change the final position. Since we do not have to over-engineer and hyper-correct this situation, we can just avoid this movement instead of going to buccal this match with having this perfect relationship in between the upper and the lower molar, and this will ensure that this movement is happening. Since we know it's highly achievable, we don't need any elastics for this to happen. We might use an attachment on the lingual side of the second molar, if it's possible, in the lower arch, because this is going to happen to improve and increase the surface of contact in between the aligner and the tooth, but it's not mandatory. It's just an option to make the biomechanics more predictable. Anyways, in case you check these contacts and these patterns, you will sure have success based on common sense mechanics.